problems related to signals and systems. Okay. In today's topic, we will see some problems from Laplace transform, Z transform, and Fourier transform. Okay, it will be just like a revision session. First problem. The problem which we are doing today also are the expected type of problem in GATE exam. Okay, first one. Compute the Laplace transform of xt equal to tut minus 2 times t minus 2 u of t minus 2 plus t minus 3 u of t minus 3. Okay, you have to find the solution of this problem. You have to find Laplace transform of this. So we know that for t, Laplace transform is 1 over s square for tut. Okay. Now, if I shift in time by 2 seconds, then my Laplace transform will be 1 over s square e to the power minus 2. Okay. If I shift in time by 3, then I have Laplace transform square e to the power minus 3. Okay. Let this be equation number 1, this be equation number 2, and this be equation number 3. Now, substituting the left hand side and by looking at the question given xt, my xt is given something tut minus 2 times t minus 2 u of t minus 2 plus t minus 3 times u of t minus 3. Okay. So for this I can write my Laplace transform xs as from 1, 2 and 3, 1 by s square minus 2 by s square e to the power minus 2s plus 1 by s square e to the power minus 3s. Okay. So this is the Laplace transform of the required signal xt. I think easy to find. So whatever the shift is there, if the shift is by 2, we have to multiply it by e to the power minus 2s. If the shift is by 3, you have to multiply by e to the power minus 3. If it is, this is left hand side shift. If it is right hand side shift, then t plus 3, then e to the power plus 3s. Okay. Accordingly, the sign of the exponential term in the Laplace transform will change. In second problem. Now, the earlier problem was finding the Laplace transform. This problem is finding the inverse Laplace transform. Compute the inverse Laplace transform. In previous problem, we have make use of some property which is time shift property. Here also we have to make use of some property. Laplace transform is given 10 times of s plus 1 upon s square plus 4s plus 3 dot e to the power minus 2s. Okay. You have to find xt out of this or the inverse Laplace transform of this. Now, I will write my xs nothing but x1s dot e to the power minus 2. Okay, this term is contributing to shift in time domain. Okay, now my x1s is equal to 10 times of s plus 1 upon s square plus 4s plus 3. Okay, if I factorize the denominator of this, I will get 10 times of s plus 1 upon s plus 1 into s plus 3. So this is nothing but 10 by s plus 3. Okay, this is my one. Okay, now we have found x1s. x1s is equal to 10 upon s plus 3. From this, if I found my x1t, let's suppose from x1s I am getting x1t as the inverse Laplace transform, I will get 10 e to the power minus 3t ut. Okay, this is my x1t. Now xs is already x1s multiplied by e to the power minus 2s. So xt will be x1t minus 2. Okay, x1 of t minus 2. Thus the finally xt is 10 e to the power minus 3 t minus 2 u of t minus 2. This is the answer. This is the inverse Laplace transform of the given Laplace function. Okay, Laplace transform. Third problem. Third problem in this, to find the final value of signal xt. Find the final value of xt. Now xt is not given in this. Instead of xt, Laplace transform of xt is given, which is equal to xs. 10 times of s plus 1 upon s into s square plus 4s plus. Okay. Solution. See, the general formula for finding the final value, that means t tending to infinity x of t is equal to limit s tending to 0 s into. So I have to see whether this limit s into xx exists. So to how to verify whether it is existing or not? See, first of all, this finally it should converge. So now what will happen? S into xs is equal to 10 s into 10 s plus 1 upon s into s square plus 4s plus 8. So this is 10 times of s plus 1 upon s square plus 4s plus 8. Okay. So if we find the poles of this s square plus 4s plus 8 equal to 0, poles are nothing but the roots of the denominator. I will get s equal to minus 2 plus minus 2. This minus 2 means whatever the function is, it is lying, roots are lying on left hand side. Thus system is stable. System is stable means it will have some finite value or it will converge to some finite point. If the case is plus 2, that means system will be unstable. Roots lying on the right hand side of the S-plane. Once they are lying on the right hand side of the S-plane, with increasing time system will become unstable or the final value of xt is going to become infinite. Now to find the value of xt, I should use again same formula, equal to limit s tending to 0 s into s into 10 times of s plus 1 upon s into s square plus 4s plus s equal to 0. This is 5 by. So this is the final value of xt, or my xt will become stable at this particular value. Okay. So these are the few problems from the topic Laplace transform. Now we will see some problem on the topic of Z transform. Problems from the topic of Z transform. The first problem in this, I will write problem number 4 in continuation with Laplace transform. Find Z transform of xn, where xn is equal to 0.8 to the power n un. Okay. Now solution of this. From the formula of Z transform, I know summation n tending to minus infinity to infinity xn z to the power minus. So substituting the xn from the question, I can write here n tending to 0 to infinity to 0.8 to the power n z to the power minus. Okay. I can take 2 common to 0 to infinity 0.8 z minus 1 the power n. Now this is a geometric series. The sum of the infinite geometric series with common ratio less than 1 is a upon 1 minus r, where a is the first term, r is the common ratio. For this also it will be 2 multiplied by a is 1 upon 1 minus 0.8 z inverse. So this is the final Z transform of signal x. Okay, simple. Next problem. Now we have seen the problem related to finding the Z transform. Now we will see to find the inverse Z transform. See, inverse Z transform is little cautious while finding the inverse Z transform. Find inverse Z transform. Z equal to Z plus 0.8 upon Z minus 0.5 Z plus 0.2. Okay. Now solution for this. First of all, we have to carry out the partial fraction of this. Z plus 0.8 upon Z minus 0.5 Z plus 0.2. I can write this as a upon Z minus 0.5 plus b upon Z plus 0.2 equal to x. Now use the rules for finding the partial fraction. I can write Z plus 0.8 is equal to a times of Z plus 0.2 plus b times of Z minus 0.5. Substitute first Z equal to 0.2 minus 0.2 and then Z equal to 0.5. So on substituting Z equal to minus 0.2, I will get minus 0.2 plus 0.8 is equal to, this term will become 0, b minus 0.2 minus 0.5. So my b is nothing but 0.6 upon 0.7. Okay. Solving this, I will get somewhere around minus 0.8571. Similarly, on the same rule, if I calculate a, I will get a is 1.857. Okay. So we have found b, we have found a. Now we have to substitute in xz. Now if I write my xz, I can write it as like this: 1.857 upon z minus 0.5 minus 0.8571 upon z plus 0.2. Okay, so x1z is equal to, okay, after writing this I am writing one more equation which is derived from xz, and let this be x1z. In this equation I will write here z upon z minus 0.5 minus 0.8571 z upon z plus 0.2. That means my x1z is nothing but z times of xz. Okay, so with this I will get my x1z in a proper form at 57 1 minus 0.5 z minus 1 minus 0.8571 1 plus 0.2 z minus 1. Okay, so I'll get x1z something like 857 0.5 to the power n un minus 0.8571 minus 0.2 to the power n un. Okay, this is my x1n which is derived from x1z. To get xn from this, okay, which will having a Laplace transform z minus 1 x1z, I will have xn. Now again time shift property, shifting in time leads to multiplication of z to the power, the corresponding power sign by which the time is shifted. 1.857 0.5 to the power n minus 1 u of n minus 1 minus 0.8571 minus 0.2 n minus 1 u of n minus 1. Okay, so this is my final xn. I think it is easy, not difficult. Only the points to remember is from the given xz I got x1z. The getting x1z is nothing by multiplying xz by z. So this expression tells that. Okay, and finally if I got this expression, it is easy to find because it becomes a known form of a to the power n un. Z transform this looks like 1 upon 1 minus a z inverse. Okay, now from this I got x1n. To getting xn from this I know x1z is z multiplied by xz. So xz is nothing but, this implies xz is nothing but z inverse x1z. So this leads to the time shift by 1. Finally you get answer to. Okay. Next problem from the same, the topic Z transform. In this problem a differential equation is given and some initial values are given. From that we have to find the impulse response, or we can say that we have to solve this differential equation using Z transform. System is described by the given difference equation. Yn plus 3 times y of n minus 1 plus 2 times y of n minus 2 is equal to 2xn minus x of n minus 1. Okay. Now we have to find solution. With this, few initial condition is given, like y of minus 1 is equal to 0, y of minus 2 is equal to 1, and xn is given is equal to a step function given. Okay. Converting a given difference equation in terms of Z transform, I can write this as, for yn I can write this yz, for 3y of n minus 1 I can write 3 outside, z minus 1 yz plus y of minus 1. 2 of yn minus 2 I can write it as 2 outside, z minus 2 yz plus y of minus 2 plus z minus 1 y of minus 2. Okay. Similarly, on the right hand side, I can convert my xn minus 1 to xz. 2 of xz minus z inverse xz minus x of minus 1. Okay. Now, after writing this equation in z domain, I can take yz one side, xz one side, then solve this. Now, I can write it like this. I can write the previous equation like this. 1 plus 3z minus 1 plus 2z minus 2 plus 2 is equal to xz. Now, xn is equal to un. That means xz is equal to z upon z minus 1. So, 2 times z upon z minus 1 minus 1 upon z minus 1. Z inverse xz will be 1 upon z minus 1, which is for xn equal to u of n minus 1. Okay. Now, yz can be written as z square upon z square plus 3z plus 2 dot 2z minus 1 upon z minus 1 minus 2. Okay. So, this will be z square upon z square plus 3z plus 2 dot 2z minus 1 minus 2z plus 2 upon z minus 1. So, this will be z square upon z plus 1 z plus 2 and z minus 1. Okay. This is my yz. Okay. I can write zyz is equal to zq upon z plus 1 z plus 2 z minus 1. Okay. So, on partial fraction, this will give me 1 by 2 z upon z plus 1 plus 4 by 3 z upon z plus 2 plus 1 by 6 z upon z minus 1. Okay. Now, the thing is, I got zyz. Let for this my time domain with y1n. I will get y1n something like this: minus 1 by 2 minus 1 to the power n plus 4 by 3 minus 2 to the power n plus 1 by 6 whole multiplied by un. Okay. To get yn from this, I need to subtract, I need to shift it by 1. So, this will be nothing but y1 of n minus 1. This is minus 1 by 2 minus 1 n minus 1 plus 4 by 3 minus 2 n minus 1 plus 1 by 6 u of n minus 1. So, this is the final. Since we have, it took time to solve this problem, but this can come as a 1 mark problem. Okay, sorry, a linked type problem, linked question in GATE exam. For linked question in GATE exam, the first part can be finding the Z transform. Okay, and next will be finding the system response. Okay, to input xn equal to step function. So, these were the few problems from the topic of Z transform. Now, next problem will be on finding the Fourier transform. There are certain plots are given. Of these plots we have to find the Fourier transform. Okay. This is question number 7. Find explanation for all the 3 problems in this topic Fourier transform is same, but the problems are different. See, first one, the plot of x is given something like this. Xt. We need to find the Fourier transform. Solution. Very easy solution. See, we know x of omega is minus infinity to infinity x of t e to the power minus j omega t. Okay. From the given figure, I can easily see that my integral range is 0 to 2. Xt is nothing but equal to 2 e to the power minus j omega t dt. Now on solving this integral, I'll solve this integral 0 2 common e to the power minus j omega t upon minus j omega 0 to 2. Okay. 2 common e to the power minus j2 omega minus j omega outside minus 1. We can take e to the power minus j omega outside. This is e to the power minus j omega dot 2 upon minus j omega e to the power minus j omega minus e to the power plus j omega. Okay. So this I can write it as 2 times e to the power plus j omega minus e to the power minus j omega upon j omega. For this I can write to the power minus j omega. Multiplied by 2 and divide by 2, I will get answer as 4 sine of omega by pi. Sinc of omega by pi, where sinc omega by pi is equal to sine omega by pi or omega by pi. Okay, to the power minus. The other way of solving this problem is, if we remember what is the Fourier transform of this. This is a rectangular pulse. Then from the given question, let this be some rectangular function of t. Then xt is nothing but 2 times of rectangular function shifted by 2, shifted by 1 only. Okay. So just apply the time shift property and get the answer. Next problem is also similar to this problem. I have my xt is equal to 2t. Okay. So x of omega will be integral 0 to 4 2t e to the power minus j omega t. Solving this integral will give me the Fourier transform of given figure. Okay. So these were the one type of problem from the topic of Fourier transform, and it can definitely come just by suppose a questioner can set a problem like this. He will give a Fourier transform of some figure and he will ask to find a Fourier transform of another figure. Now the figure which is given in the question, or the figure for which the Fourier transform is asked, that particular figure can be derived from the figure for which Fourier transform is given. Okay. that figure can be derived either by shifting or by adding something or by multiplying something. Okay, so we should use the properties of Fourier transform while finding the solution of such problems. Okay, so this completes the problems and topics in the signals and systems. I hope we have covered many problems and different varieties of problems which can complete the full syllabus. Okay, these are the major problems which are coming across in this unit of